from a data protection standpoint, the core thing is if you can encrypt the data, encrypt it. I mean,
Just do
honestly,
it.
yeah, at the end of the day, just encrypt the data.
Welcome to the Reimagining Cyber podcast, where we share short and to the point perspectives on the cyber landscape. It's all about engaging yet casual conversations on what organizations are doing to reimagine their cyber programs while ensuring their business objectives are top priority. With my co-host, Stan Wisseman, Head of Security Strategist, I'm Rob Borrego, Chief Security Strategist, and this is Reimagining Cyber. So Stan, who do we have joining us for this episode?
Rob, Chris Abramson is the Senior Director of Cloud Security Engineering at Walgreens. Chris's career spans over 20 years while working inside companies from the Fortune 50 to as small as 10 employees. And Chris, it's great to have you with us today to help us better understand how to take secure cloud computing to large environments. You've been working with Azure Defender for cloud security, as well as helping secure applications as they're doing dev test and rolling out into production. So it's a hands-on kind of experience for our listeners that are trying to deal with these issues. Can you expand a little bit on your background for our listeners?
Sure. So interestingly enough, my background actually didn't start in cloud. I'm an app developer by trade. That's where I started. And coming into security was kind of I'll call it a mishap. I hadn't actually anticipated going into InfoSec. I was on the programming route, and then all of a sudden, things happened in 2008, around that, that period of time, or not 2008, a little sooner than that. That just led me into the security path, and that's where I ended up. And now, over the span of the last 20 years, my roles have changed. Governance, technology, governance, back to technology, and today now it's in the cloud space.
Gotcha. Well, Chris, in 2019, I believe it was, Walgreens inked a deal with Microsoft with plans to move most of its IT workloads to Microsoft's Azure public cloud. And I'm sure that is keeping you very busy as the one that's sort of like on point for securing cloud workloads. So the consumption of cloud services at that kind of scale must be pretty daunting in the sense of having to rethink how IT operates in the broadest sense, and how security fits into these new processes. So, how have you navigated this transition?
Well, a good chunk of it has been kind of a Microsoft first approach. We've had to rethink strategy. On-prem has always been about firewalls and IDSs and IPSs and technology that you wrap around an environment, maybe not so much in the environment, even though more companies have trended towards like EDR solutions on their servers and being able to monitor what's happening. But in the cloud, you're working in what equates to a highly coded environment, and so the nature of how things communicate with each other and talk to each other, that's been the biggest change for us, is how do we adapt to that type of world, and how do we adapt to securing that type of world?
Well, Chris, one of the things is also focusing on, how are you actually shifting these application workloads to the cloud? And there's organizations have taken different approaches, right? You have the kind of lift and shift approach versus the, we're going to go cloud native, and you're going to take advantage of different services from the CSP, in your case with Azure, of course, right? Mm-hmm. But there's multitudes of different deployment models, and there's probably some different kind of aspects of that in play, even with what you're doing within Walgreens. How have you gone about establishing some of the guardrails, right, to ensure that the security really truly is not being left behind?
Sure. So a lot of our teams work a lot with ARM, a little bit with Terraform as well too. And so what we've done is we've partnered with our cloud COE organization, and we've designed security into that deployment model. So where we're deploying, I'm trying to think of a good example, but I'll just say we're deploying a VM to an environment. Okay, we've built into that CI/CD pipeline the security model that we want wrapped around that. So as our teams, whether it be an infrastructure team or even an application team, go to do that deployment, they're hitting the gates of security not at the end, not after everything's deployed, and then we have to go back and like try to figure out, okay, how we're going to wrap security around this. But they're hitting it as they go, so they can make the changes, address the configurational issues, and then deploy in a way that is appropriate in our environment that poses the least risk to the environment as well too.
So for our listeners, ARM is basically the infrastructure as code kind of approach, right, for Azure. Right?
Yeah, the Azure Resource Manager platform. So
that's
sure
like that management capability level to be able to actually do those kind of deployments. And so you're using that as part of your gates, but are you also reviewing kind of the ARM templates that development is using?
Yeah, we go through a process with the teams where we develop the ARM templates alongside them. So instead of a team going off and, okay, we're gonna go build an ARM template to deploy Azure Databricks, okay, and they go deploy it, and then they got to like put it through a process with security. No, we work with them, alongside them, to make sure that as it's built, as the code's being generated, as the checks are being done, all of that's put in there, so we don't have to do this back and forth with our teams. It's inefficient. It takes a lot of time. It takes a lot of effort. So it's a partnership between the two organizations, and by doing so, we've created this pod model where teams will get together. They'll focus on a PaaS service, and they'll start to build out that IAC design, that infrastructure as a code design, with the security checks available to them.
And as far as how rigorous do you apply those checks? Is it by risk as far as the risk level, or how do you, or is there a differentiation?
How do we make a decision on what checks we're putting in there?
Yeah.
You know, we've established our own model of guardrails, things that we know by experience or by way of industry knowledge. These are the gotchas. These are the things that are going to hit you in a security model. I'm not going to name them off. I don't want to give away the secret sauce to anybody, but we have taken a risk-based approach. Things that we've seen in articles that come through CVE data on vulnerabilities in the cloud, things that have been experienced by other companies, made public, whether through articles or industry groups, etc. And so we're taking that experience and we're baking that into our design. So is it risk-based? Yes. It's more fundamentally, though, what's going to prevent bad behavior, things that we don't want to have happen in the environment.
One of the things that we've seen, let's say not taken as seriously previously, were the access controls relative to code repositories, right? Kind of loose in the past. But obviously, there's been a lot of changes in specific exploits at the code repos that needs to kind of change the way things are approached and actually be more rigid in the access control, be more rigid understanding, who has rights back in, but access back to pull data back out, to pull the details that we're seeing. And one of the, obviously the ones that we're all very aware of as a main kind of, light the fire on this was around what happened with SolarWinds, right? It's a prime example of it. So if you look at what kind of happened back then, about now almost a year and a half ago, how has that kind of changed? And what are some of the thought processes that you have taken in recommending different approaches for how you're really taking and locking down those code repos?
Yeah, this is a tough one, because development teams always want the ability to grab libraries, grab things that are going to help them move quicker, get things done, deploy code. This is one that is still kind of an evolving space. I think just for anybody, it's still an evolving space. And especially in a large company where you have a lot of development teams that are working. This is one that fundamentally really takes a lot of interaction between development teams and the security teams to make sure that they're thinking about what the impact is going to be if they pull from some rogue repository or just off the internet and things like that. A lot of education, a lot of back and forth. But there's also tools that we've implemented that let us look at particular libraries things that we feel are going to have major impact in our larger applications and such. So we do take a hands-on approach with them, but I think this is always going to be an evolving space because of the nature of just how software development moves quickly and things want to get done fast. So,
and just a follow-up question on that, Chris.
Sure.
I mean, we're seeing a lot around that whole area around securing the software supply chain.
Yep.
And getting things, one areas of trying to lock things down is around the code repo, like we were just talking about. But there are other injection points, right, that bad actors can, take advantage of. But also it could be an unintentional kind of insider threats to developers and unintentionally adding risk. Are you looking at that, or not necessarily you, but is your organization looking at software supply chain risk management as an area of focus?
We are. I think going back to I'll kind of go back to the days of PCI where third-party risk management kind of started the ball rolling on this for a lot of companies. It's evolved. There's that word again. It's evolved. It's kind of moved on from just the person that you got to worry about to now you got to worry about the person's person in that model. You got to think about software that you're buying from a third party that now also embedded software from another third party that likely embedded software from another third party.
It's like
That's
the Russian doll syndrome.
It is the Russian doll of software. It's the concept of how do you know that you're comfortable with what's going on, what you're bringing in, whether it's a COTS application, or some SaaS platform, that you're going to integrate through an API gateway of some kind, that you're comfortable with letting those connections happen. And that's really what it comes down to is where you're connecting, how you're integrating with these different platforms and such, because you likely might buy something that you don't ever plan on integrating into your systems. You're going to use it for something low risk. You may not care, versus you're going to integrate it wholeheartedly into your environment. Now it becomes a higher risk scenario. I think it still starts with a strong vendor security management program, talking with your partners, understanding their security practices, what they're doing, and how they're managing their code, their releases, their ingest of those same platforms or same libraries or same third-party integrations as well too.
And that's why asset management, right, and some kind of bill of materials associated with
Yep.
what consists of that application is very important, right?
Yep.
So Chris, the CI pipeline needs secrets to operate because it needs to communicate with other systems to deploy stuff and access multiple things. These secrets don't belong in the code and all the systems to provide smarter ways of dealing with those secrets. But you need to ensure that these methods of securing secrets are being used. So otherwise, if you hard code your secrets, these tools won't stop you from doing so. What methods have you taken, and then what do you recommend using to detect proper sharing of secrets and code and infrastructure as code templates?
So I think there's a two-pronged approach here on this one, Rob. Number one is a strong threat modeling design around application environments and how they're ingesting that material. That comes with an upfront architecture review or utilizing tools that allow you to map your environments out to know where you're connecting, why you're connecting, in what fashion you're connecting. Are you encrypting the traffic, things of that nature. And then the second part of that is recursively coming back over time. The secret stash, so whether it's a key vault, you're using something from HashiCorp, to integrate your whatever it is that you're modeling behind. Obviously, the main thing you don't want to do is you never want to put a hard-coded password or a hard-coded key in your code. Like that's just downright insane in this day and age, because you have no idea who's going to touch that code, who's going to see it, which third party is going to have access to it. You want to make sure that you have a strong chain of custody around the password, the certificate, the key, whatever it is that you're trying to secure for whatever purpose. So it does come down to that threat modeling piece, but then also coming back over time and recursively, are you updating? Are you reviewing who has access to those things? Are you looking at what it's being used for still. Did you renew it? Does it expire? There's a little bit of what we all kind of refer to, I think, in the industry as cyber hygiene. You got to come back and look at those parts and pieces over time and decide, did I do it right? Did I implement it properly? And is it getting updated? Is it getting replaced? Is it getting renewed? Is it being changed?
And getting that visibility that there actually
Yeah.
are secrets there. And sometimes you have to scan that code to find that perhaps they haven't
done that. Yeah.
Right?
What you don't, yeah, exactly what you don't know. And there's some really great products that I see coming out on the market that help with that threat profiling, even on a recursive basis, where they can identify things like what we're talking about here, like secrets exposure or misconfigured systems, lack of TLS. I think teams really need to start thinking about that, especially as their environments start to grow or they start to expand out beyond the reach of just a general like paper review or something of that nature. So I think there's some really good stuff coming out in that space.
Well, one of the challenges we always run across is how to protect your sensitive data, right? And especially when you're dealing with cloud data warehouses and those kind of analytic platforms that are large repositories of data, juicy targets, right? I think that, the processes that you're probably putting in place to help gain visibility into that data as it's moving into the cloud, and working with your business units to help ensure that they're protecting that data, and how it's being accessed. What kind of approaches are you taking to help ensure that everybody's in line and in sync and has that visibility?
So I think, from a data protection standpoint, Stan, the core thing is if you can encrypt it, if you can encrypt the data, encrypt it. I mean, honestly, yeah, at the end of the day, just encrypt the data. Now, for a lot of companies and we're included in there, there's times where encryption it doesn't work. Whether it's you're trying to do analytics, you're trying to do stuff that you can't. Encryption doesn't give you that ability to do. So there's other ways that I think companies need to think about this, and other ways that we've thought about it. Wrapping environments in a model that doesn't allow access to or very limited access to. It's kind of the I'll call it the vaulted environment. The no ability to touch, change, maneuver through, or ingress or egress without somebody watching you do it. That's tough. It's expensive, and it's highly operational because there's a lot of eyeballs having to do that. Hence why I say if you can encrypt it, because honestly, encryption is the quickest, easiest way to protect your data. And if somebody can't walk off with the keys, then you're in good shape, and they can't walk off with the data because it's encrypted. So, and in that space, I recommend a bring your own key model, especially when you're in the cloud, because especially if you're in a hybrid world, your workloads shift, move, go from one environment to another, one region to another. And, all the cloud providers, I think, have solid, physical security controls and even, logical security controls, but there's always that one-off chance. And I recommend don't take that chance. It's just don't do it. So if you can, bring your own key and encrypt the environment. So that's really your safest bet. But I think in a lot of ways, as companies start to realize that they need data to do business processes or analytics or marketing or whatever the model is that you got to do, there's going to be times where that just doesn't work, and you got to be prepared for how you're going to approach that as a security organization, how you're going to partner with the business side of the house and IT side of the house, and how you're going to help them expose themselves as little as possible to the rest of the world, and how they protect that information.
Well, Chris, I mean, coming on and sharing with us some of the different things you're doing, we really appreciate it. I think you've only been doing this for 3 years, the aspect of the cloud journey within Walgreens. And just in that time, the progression that you've made is it's we know a little bit more behind the scenes than what you're hearing today. It's pretty impressive. But
it's pretty staggering. I got to give a lot of credit to our cloud organization, as well as our internal security organization and actually the application teams as well too. It is definitely a team effort when it comes to doing cloud, because it is highly complex. There's a high number of touch points, and it can go bad very quickly if you're not careful. If you're not careful, it can go bad very quickly.
Well, it speaks volumes to what you're sharing as far as, all the different components to it, but the teamwork that you guys have been able to really pull together and actually get on the same page to make it happen, right? The examples you shared around how you really do have kind of the security gates along the way versus let's wait and see at the end what the actual security issues are. And then everybody has to go back. And now we've killed all this time, right? And now people aren't happy about that, right? The traditional battles that we've had in the past. So great shifting in there. And then my favorite is the new t-shirt that we're making for you, which is just encrypt it. So that's great. Right? We'll have to maybe talk to Nike about it, but we'll get you.
Sounds good, Rob. I'll be waiting with bated breath for that shirt.
Yes, indeed. We'll have it delivered. So thanks again for coming on. We truly appreciate you sharing your experiences there.
Absolutely. I appreciate it. Thanks, guys.
Hey, thanks, Chris.
Thanks for listening to the Reimagining Cyber podcast. We hope you enjoyed this episode. If you would like to have us cover a specific topic of interest, feel free to reach out to us, and you can find out how in the show notes. And don't forget to subscribe. This podcast was brought to you by CyberRes, a micro-focused line of business, where our mission is to deliver cyber resilience by engaging people, process, and technology to protect, detect, and evolve.